I'm now going to look at a situation where the coefficient of x squared is not 1. So we're going to try and again use the completed square method in order to do a sketch of this graph, a graph of this rather. Okay, so what we would do is we can use the formula that if I've got something like x squared plus bx plus c, a function of x in this form, I can actually write it as f of x is equal to x plus b over 2 all squared minus b over 2 squared plus c. So in our case, it's not quite in that format yet because we've got a number in front of the x squared. So what I'm going to do is I'm going to take my function, so 2x squared minus 8x plus 1, and simply take out a factor of 2 and put everything else in a bracket. So I'm going to have 2x squared, so I'll use a square bracket at this moment. So 2x squared, and then this is now going to be minus 4x, and this is going to be a half. So now it's in a format, the bit in the square brackets, where I can apply the completed square. So I can say, well, right, I've got 2, and then now just working on the x squared minus 4x plus half, I've got x minus half of the coefficient of the x, there is 2 all squared. Now what I'm going to do is take away this minus 4 halved, so it's b over 2 there. So minus 4 over 2 squared, and then plus the half. So if I try and tidy that up a bit, I've got 2 outside the square brackets, I've got x minus 2 squared, the bit inside this second set of brackets here, minus 4 over 2, will simplify to minus 2, which if I squared it would give me 4. Not forgetting, even though that's minus, if I square a negative number, I get a positive answer. So it's going to now be 4 there. The bit in the brackets squares to be a positive, but I was still taking it away in the first place. And then plus a half. Just tidy that up a bit more. So I deal with the minus 4.5. So I've got 2x minus 2 squared. 4 could be written as 8 over 2. Minus 8 over 2 plus a half would be minus 7 over 2. So now if I multiply back through by the 2 that's outside the brackets, I end up with 2x minus 2 squared, and then 2 times 7 over 2 just gives me 7. So it's actually in the format that was asked for in the question. And what I'm going to do is I'll first of all solve this actually. So solve f of x equals 0. So what we would do, we'd take the 2x minus 2 squared minus 7, and we'd equate that to 0. And then what we'd do, we'd just unravel this equation and make x a subject. So we would say we've got 2x minus 2 squared, and then we could add 7 to both sides. So we'd end up with that. Then we could divide by the 2. So we'd end up with x minus 2 all squared equals 7 over 2. Then we could square root. So I've got x minus 2 equals square root of 7 over 2. Not forgetting that we can have a plus or minus answer to that one. and then I would add the 2 there, so I'd end up with x equals 2 plus or minus square root of 7 over 2. So that's how we could use the completed square method to solve this equation. If we now wanted to do a sketch of this function, it's handy that it's in this format. So we can base it on our original y equals x squared graph. So here it is. So our y equals x squared graph would look like this, with the minimum point being 0, 0. If we look at, first of all, translating it to, or transforming it to y equals 2x squared, so we can do this in a series of steps, then what the 2 in front of the x squared has the effect of is just stretching it by a factor of 2 in the vertical axis in the y direction. So what that's going to look like then is pretty much the same shape as this one, only if I do it in a different colour, it would look like this. It would actually be just stretched with a steeper value. So that would, steeper gradients, that would be y equals 2x squared. Y equals 2x squared. And then what we'd be doing is a translation on that graph. So on the graph of y equals 2x squared. And we can see that we've replaced the x in there by x minus 2. So it's a translation of this graph of the y equals 2x squared that we've just drawn in blue by 2, because we do minus whatever is in there. So if it's minus 2, it's going to go to positive 2. And then whatever we've added on at the end, that's the translation in the vertical direction, in the y direction. So we're just going to translate the graph of y equals 2x squared by this vector, 2 minus 7. So what that's going to give us, let me do that again. That's going to give us a minimum point now, which rather than being 0, 0 has been translated to 2 minus 7. That's going to be the minimum point, and we can then find the other values if we want. We can find the points where it's going to cross the axes as well. So as a very rough sketch, what we could do would look something like this, with the minimum point moved from 0, 0 to 2 minus 7. And we could stop there, but I'm going to carry on now, so I'll find the other points. If that was all you was looking for, it was just simple to find where the minimum moved to, and you could stop watching at this point. But I'm also going to continue now to find the points where it crosses the axes, so these 3 points. So continuing from where we got up to, we'd got our original function 2x squared minus 8x plus 1. We put it into completing the square form, 2x minus 2 all in a bracket squared minus 7. And we'd found the solution for f of x equals 0 by using the completed square form. We'd got it as this value. And if I work out what those values are, because that's in exact form at the moment, which is great, but we might want it as a decimal in order to be able to plot them, we would get 0.13 and 3.87 as the two values that these would work out to be. So if we try and put this onto a graph, let's try and plot those points. And what we end up with is we first of all found that the minimum point was at 2 minus 7 as before. So we've got this point here. We also get that because f of x equals 0 for these values of x, then they are actually the roots of the equation and where it crosses the y-axis, the x-axis. So they would cross here and here roughly, 0.13 and 3.87 with these 2 points. And then we also want to find out where does it cross the y-axis. So all we need to do for that is it crosses the y-axis at x is equal to 0. So we could put that into either one of these. I'll just put it into the first one because it's easier to substitute in at that moment, because we get 2 times 0 squared minus 8 times 0 plus 1. And that just works out to be 1. So we know that that point is 1 there. And then all we need to do is we just need to plot it. So to do that, it's going to look like this. So obviously we're trying to draw it going through the actual points I've put on here. So that's it for that question.